Hello everyone, my name is Gurnoor Singh and this is my video submission for SIT315M3T1P MPI matrix multiplication task. And what this task involved was basically creating three programs. Part A with just MPI, second part collaborating MPI with OpenMP, and part three was making MPI with OpenCL library. And for this one, the first I'm going to do is demonstrate my part one. In this one, you guys can see that I've used MPI library only. Uh, in case of matrix multiplication, I've used a generating matrix function here, which is going to generate random values for our matrices. And then in the main function, I have initialized MPI library, which is going to take the rank and size of the matrix. Afterwards, we move on to the unsigned long part. So this is basically a user input validation for the user in order to get the dimensions of the matrix. And it's made sure that we are using a matrix dimension that is divisible by number of processes that we have. And further moving on, we have the MPI broadcasting and barrier functions. And what they basically do is MPI scatter the rows of A into all the processes, and then broadcasting is basically for moving the matrix B into the all processes. Afterwards, we have the three nested loops, as you guys can see, which are responsible for the core of the matrix multiplication. And then a reduce function is used to compute the time that has been spent across all the matrices, processes actually, in order to get the output. And then gather function is used to collect all those results. And then the maximum time output is then printed out to the terminal. And what I will just do is print the output that we achieved from this one. So I'll just go, first of all, control save. Yeah, terminal, new terminal. MPICXX, and the file name is matrix multiplication underscore MPI.cpp minus O matrix multiplication underscore MPI. Yeah, compiled. In order to run this, MPI run. And so what I'm doing is basically using 4 processes at the moment. And then file name is again CPP. And my matrix size is 1000. So dimension is going to be 1000 by 1000 matrix, which is considerably large. Oh, I made a mistake here. Okay, my file name is not correct. Sorry. MPI run minus np4 dot slash matrix multiplication underscore MPI. So yeah, as you guys can see, the calculation is done, and the maximum time that has been taken right now, that is 0.934946, which is considerably close to a second, but quite a small amount of time when we compare this to sequential or multi-threaded programs, which in case of sequential can take up to even half a second. So that is much more of a good output that we have here. And we will just move forward into a second program and then compare the outputs with that one as well. So yeah, I'll just delete the terminal here that I have and move on to my second program, this one, which uses MPI library in collaboration with OMP. And OMP, as we remember, is a multi-threading program. And what it does is basically, since MPI is going to divide the processes further, OMP is going to further divide those processes into threads, which is basically creating more shares of the same processes, uh, which makes a program much more faster. And we'll just observe the results that we have. Again, generating matrix function in order to generate the matrix, initializing our MPI rank and size. Afterwards, we move on to generating our matrices. Again, scatter and broadcasting function for the similar processes. That is distributing the matrix A and then giving matrix B as a whole to all the processes. And then as you guys can see, I have implemented my OMP parallel in the core of my 3 nested loops. And yeah, reduce and gather function, same process, and basically printing the outputs into the terminal. So let's go terminal, new terminal. And in this one, so my compilation commands for this one will be PICXX. Yeah. File name is matrix application underscore PI underscore MP dot CPP minus O matrix underscore PI underscore MP minus F open MP. And what I'm going to do is basically something different. That is initialize the number of OMP threads that I'm going to use in each process. OMP num thread is equal to, let's say, 4 in this case. Oh, I guess. Thread. This should work. Yeah. Num thread is 4. So each process is going to go with 4 threads now. And what I'll do is MP. Now run this npr run minus np 4 dot slash MPI underscore OMP, and matrix size again is 1000. So yeah, now my output is 0.86289, which is significantly lower than MPI library program that we observed earlier. And that is because now what's gonna is happening is basically there are 4 processes, but then each of those processes is going to be divided into 4 threads each. So it's much more, you can say 16 times faster. Uh, that's why we are having like consider, let's say, about 10 seconds slower. Less time is taken for each calculation to occur. So yeah. So that's the second program, a bit faster than the just if we just use the MPI library. But yeah, now what I will do is just move the same process to my OpenCL program here. So this is the part C, and within this one we have used MPI, but in collaboration with OpenCL library. And this one is so the thing with OpenCL is instead of CPU, it's going to use GPU in order to perform any kind of calculations. So yeah, initialize my MPI, uh, made sure the dimensions are correct. Generate matrices, again, scatter and broadcast functions used. Afterwards, you can see I have initialized my kernel here. And yeah, so that's the whole program that I've used. Now what I'm going to do is run this one as well. Make sure it's saved. Terminal, new terminal. Yeah. So for this one, PI6 file name, matrix multiplication underscore MPI underscore CL dot C. So here, this will be open. Yeah. And the thing with MP run, yeah, it's MP4 dot slash ship. And my matrix, sorry. So yeah, you guys can see this one now. For this one, my number of processes again were 4. My matrix size was 1000, but this one didn't need any number of threads as we needed an earlier program, because it's going to use GPU, which is sort of much faster than a CPU. And you have about like 0.039 seconds, and which this is like considerably slow when we consider a 1000 by 1000 matrix. even when compared to a multi-threaded or sequential programs. This is a much faster result because for such large matrices, sequential just becomes unapplicable. And multi-threaded does give us results, but not as good as this one. So yeah, this is the outcome that I've achieved from all three of my programs that I have created. And this is conclusion of my video submission for SIT315M3T1P. Thank you.